In which of the following species is the underlying carbon having sp3 hybridization? Now these are the four options and we have to tell which carbon is sp3 hybridized. In cases of carbon atoms, this is a short trick basically. In cases of carbon atoms, what we have to do, we first of all, we only calculate the number of sigma bonds, right? In these cases, you just calculate the number of sigma bonds, and if the number of sigma bonds is 4, that means 4 orbitals is used, you can write the hybridization as sp3. If the number of sigma bonds present is 3, then the hybridization is sp2. If the number of sigma bonds is 2, then the hybridization is sp, right? So this is basically a short trick. Now let us see what is given in the question. The question says CH3, A option, this is basically the A option, CH3, C double bond O, OH. Now we have to calculate the hybridization of this carbon. How many sigma bonds it is forming? 1, 2, 3, right? These are basically the sigma bond. This one is the pi bond, right? So basically it is having 3 sigma bonds. That means the hybridization is given by sp2, right? Second part is CH3, CH2 basically. H2 means HHOH. How many sigma bonds are there? 1, 2, 3, 4. So that means 4 sigma bonds are there. There is no pi bond. That means the hybridization is sp3. So that means B is the correct option. Now let us also see the C part and the D part as well. CH3, C double bond O, CH3. How many sigma bonds are there? 1, 2 and 3. Basically here also we are having 3 sigma bonds, which means sp2 hybridization. Now if we talk about the D part, it is CH2 double bond CH3. How many sigma bonds it is having? 1, 2 and 3. 3 sigma bonds are there. This one is the pi bond. That means the hybridization here also is sp2. So that means only option B is correct, right? So this is basically a short trick which can be used majorly only for carbon atoms. It can be used for other atoms also, but I'll tell you this, if you're doing it for other atoms, then you have to also take into account the number of lone pairs present. For example, in NH3 if I talk about. In NH3, what is happening? N is making 3 sigma bonds with H and there is 1 lone pair, right? So the total hybridized structure will be 1, 2, 3 and you will count the lone pair also, 4. That means sp3 hybridized structure, right? So in other atoms you can use this short trick as well, but in other atoms you have to use this lone pair also. Here in case of carbon atoms, lone pair is not used just because it does not have any lone pair. It is forming all the bonds, right? So that means in case of carbon atoms, you just have to calculate the number of sigma bonds present. But in cases of other atoms, you have to calculate the number of sigma bonds plus the lone pairs, right?